So, good evening and welcome to Matlab and OCTAVE Programming with Ajibola Bolaji Jetro. That is my name. This is lecture 1.0 for the Matlab and OCTAVE learning. Okay, so what is Matlab? That's the first question that comes to most people's mind when they hear about Matlab. Oh, Matlab, I've been hearing about Matlab. What is it used for? So, Matlab is a programming language developed by MathWorks. This tutorial video will give you a basic introduction of Matlab programming language. Furthermore, this tutorial video is designed to give students fluency in Matlab programming language, and problem-based Matlab samples have been given in simple and easy way to make your learning quite fast and interesting. So, I want to assume that you have a little knowledge of any computer programming and understand concepts like variables, constants, expressions, statements, and so on. So if you are not done programming in any other high-level language like C, C++, or Java, then it will be very much beneficial, and learning Matlab will be like a fun to you if you have done programming in any other high-level language like I listed earlier. Before we look at the basic syntax in Matlab, I would like to take you through an overview of Matlab. So we can use Matlab to deal with matrices and arrays. You can use it for 2D and 3D plottings and graphics. You can use it to solve linear algebra, algebraic equations, nonlinear functions, statistics, data analysis, calculus and differential equations, numerical calculations, integrations, transforms, curve fitting, various other special functions, as much as you can list them. So Matlab is widely used as a computational tool in science and engineering, and this is encompassing of all fields of physics, chemistry, mathematics, and all engineering streams that you may think of. So it is used in a range of applications including signal processing and communication, image and video processing, control systems, test and measurement, computational finance, computational biology, and so on. So I won't like to dwell on that, mainly since this is an hands-on practical. So in the Matlab we have the command windows. Let me take you to the Matlab environment. So I'm using Octave instead of Matlab. Octave is very similar to Matlab. Octave is almost the same with Matlab. It's just a very small difference we have between Octave and Matlab. So this is Octave we're using, and this is our command window. We are on the command window by default, and you can see the two greater than signs. Yes, that is your command line. So when you input something like x equal to 23, so it gives you the value in answer. Can you see it? So it gives you x equal to 23. So let's assume I want to compute 24 plus x now. Can you see it? So the answer will be 47. So what the Octave compiler has done now is to take the value of x and add it up to 24 that I just introduced. So you get it now. So this is the command window. We'll be using the command window for now before we proceed to using scripts and all of that. So you can also use it to compute something like this, 3 raised to the power of 2, to give you 9 definitely. Also, I want to divide 50 by this, your division symbol in Octave. 50 divided by 0, for instance, you know it is infinity. That's why it's giving you INF. So that is that about our command windows in Octave. So using semicolon, how do we use semicolon and what do we use semicolon for in Octave? Let us look at what we use semicolon for in Octave. So semicolon indicates the end of statement. However, if you want to suppress and hide the Matlab output for an expression, you can add a semicolon after the expression. For instance, I type x equal to 23 without semicolon now. If you notice, it will bring back x equal to 23 for me. But what if I want to suppress this? I don't want it to repeat what I typed before, so I want it to suppress it somewhere. Then later when I need it, I call it, it gives me back. What if I type x equal to that same 23 and you add semicolon? Semicolon is that full stop and comma symbol. So when you execute this, you see it won't bring back the value. How do you execute? You press enter as if you want to create a paragraph. So that is it. Now I want to have something like this. I want to also have y is equal to the value of x plus y. Okay, let me say plus 4 now. Sorry. So it gives me 27. That means that's added up the value of x and added 4 to it. So that gave me 27. So that's all about semicolon. Semicolon is used to suppress an expression or to indicate the end of a statement. Now, when you click the what's it called? The enter button, it immediately suppresses it. That's what happened around here. So let's go back to our outline. The next thing I'll be teaching you now is to add comments. How do you add comments? What do you need comments for? So in Matlab, to add comments in your programming line or your program line, to add comments, you can use the symbol, percent symbol, that's it, to add comments. So for example, you can wish to write, okay, assign the value of 5 to price. Now when you press enter after typing this, the compiler will overlook whatever that comes after percent symbol. That means it is a comment, is just there to explain what is happening, but you are not to run it. That is, the compiler is not to run it. So what I just explained now, that's what I want to write in the code now. So I want to give price to be equal to 5. Sorry, I misspelled price. So this is it now. So price is equal to 5. Have you seen that? That's how interesting Matlab is. So back to our outline. Now we have some commonly used operators and special characters in Matlab. So this is plus symbol. We use it to add. This is the addition operator. So we have the minus symbol. It is the minus operator, or you call it subtraction operator. Then we have the asterisk. We use this for multiplication. So this is exponential symbol. We use it to raise to power. So we have this is the division symbol or operator. Then this is the colon. Have you seen that? This is the colon. We use it to generate some regularly spaced elements and represent an entire row or column. As we proceed, you see the usage of all these symbols. Then this is semicolon. I explained what semicolon is used for earlier in this video. So we use it to suppress display or separate columns. So this is percentage symbol. We use percentage to write comments. Then this is equal to, we use this to assign. This is an assignment operator. Then we have some special variables and constants. Oh, These are some special variables that you can't use it for any other thing. The compiler recognizes it as a special variable. ANS, it means answer. So whenever I see ANS, it's talking about the most recent answer. EPS is talking about the accuracy of floating point precision. Yes. So we have the INF, which means infinity. I and J are actually imaginary units. The NN means not a number. Yes, so it's an undefined numerical result. Remember when you type something that is actually a mathematical error on your calculator, it shows math error. So math error and NaN is somehow close. So pi, you all know what pi is, I guess. So we want to look at variables in Matlab. Variables in Matlab. So how do we know what variables are? So if you want to clear this line of code, you can just use this command clc. You see, it clears everything. Now in Matlab environment, every variable is an array or matrix. So the Matlab takes every variable as an array or a matrix. So you can assign variables in a simple way. For instance, you give Matlab x is equal to 3. You see, it returns x is equal to 3 back to you, and before returning, something happens. It registers 3 in x. I hope you understand. So let's look at x equal to the square root of 16. You all know square roots. When you want to enter square root in Matlab, you use this. Square root of 16 now, it gives us x is equal to 4. That means the answer to that function that we have there. Now please note that once the variable is entered into the system, you can refer to it later. So I can actually call this later. Maybe I want to say now that y is equal to x plus, let's say, square root of 25. Whatever function you want to have should be in the bracket. So you see, it gives me 9. That means that added 4 and the square root of 25 together. So that is it. Now we want to try another thing again. Okay, we can still use, remember I said the other time that ANS is actually a variable. Now my most recent answer, which is ANS, is what? 9. So I can say 900 divided by ANS. That is my most recent answer. Look at what it gives me. 0. So I think, no, there is a problem here. Sorry, it shouldn't give me 0. Let me do this. Let's see the square root of, for instance, 144. The square root of 144 is 12. Now I want to divide 900 divided by my most recent answer, which is ANS. So it should give me 75 definitely. I hope you understand. So let's look at this other example. What if I have x times 7.80? You see, x is equal to, I wanted to say, 7.80. Remember to add your semicolon so that it will suppress the answer. So I used colon instead of semicolon. So let me return it. So now it has suppressed my answer. Can you see I used colon instead and it's showing me error? So I immediately corrected it to a semicolon. So x equal to 7.80, and I want y to be equal to x times 7 without semicolon. Now that means I want it to show the result. So our answer is equal to 54.600. I hope you understand that now. So you can also have multiple assignments on the same line. You can still use the semicolon to separate that. So what if I want to have something like, okay, let's say the prices of some grocery items, for instance, milk is equal to 200 naira, colon, semicolon, sorry, space. You have a sugar is 150. We are trying to define the prices of some grocery items now, and you have let's say cheese to be equal to, let's say 300 naira. Now I add these two. Hope you are following. Now I now want to, that's a colon, not a semicolon, sorry. Please be very careful, not always make this mistake. Now I want to now have grocery, that is, how much did I spend on groceries, will now be equal to milk plus sugar plus cheese, then execute. Now sorry, execute now. Okay, there's a problem somewhere. Let me try taking this to another line. Okay, sorry, let me clear my screen. I think there's a passing error here. Let me clear my screen. I declared milk as equal to 200, sorry, milk is equal to 200, sugar equal to 150, cheese equal to 300. So I want to have grocery to be equal to all of those items. Grocery to be equal to milk plus sugar plus cheese. Now, so you see, grocery is equal to 650. That was what I was trying to do. Grocery is equal to 650. That is that it has added all of those things we listed earlier. So that is multiple assignments for you. That's what I just finished doing now. Oops, I have forgotten the variables. Oh, the variables I used, I can't remember again. The Matlab will definitely show you all your variables. How can you recall the variables you have used previously on Matlab? Just type the WHO command. WHO should show you all the variables you have used. You see, today I've used A, I've used answer, I've used bola, I've used cheese, grocery, milk, price, sugar, X and Y. These are all the things we have used today. So it will bring it back. So for you to remember the variables you have used before. Okay, there is another command, WHOS. What does it do? WHOS command displays little more about the variables, the kind of memory space they occupy and the type of each variable, the memory allocated to it. And so let's execute. Let's see. You see, A is a 1 by 1 matrix. Can you see it gives the kind of data type it is double double, and it showed us the memory space it has consumed. I hope you all are following. So that is that. Now, long assignments. Long assignments. How do we get to explain long assignments? So if you want to explain long assignments, it can be extended to another line by using an ellipsis. You all know ellipsis, those three dots. For example, let me clear my memory. CLC, as usual, you clear your memory. Now you have initial velocity. So type it, initial velocity. Want to see how to create a long assignment on your Matlab? Initial underscore velocity. Okay. We declare it to be equal to 0. You all know in physics your initial velocity is always equal to 0. Then we want to have our acceleration. I'm going somewhere, just follow me. Acceleration equal to, let's say, 9.8. 9.8. So we have time to be equal to 20. Then we have a final velocity. Now we want to know what our final velocity is when it calculates all of these variables we have listed above. So our final velocity will now be equal to initial velocity, initial underscore velocity. So want to have, now you add this ellipsis. Now this is actually showing you it's a long assignment. So we break, then you can continue, plus acceleration. So the ellipsis is just to make you break and continue, times time. So you see, it gives you your final velocity to be equal to 196. So the long assignment, that's the dot 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 sign, is to just make you break. Maybe you are typing something on a line and you feel it's too jam-packed, you can just use your ellipsis to break it into the next line. I hope that is making sense to you and you are following. So next we are going to look at the format command. So by default, Matlab displays numbers with 4 decimal place values. This is known as short format. So however, if you want more precision, you need to use the format command. So the format long command displays 16 digits after decimal. Let's look at what I just explained now. It's very simple. So we want to format what is it called? The value of this operation we want to do. I said by default short format. This is its short format is the default formatting you have on your Matlab for a data type. So if you want more precision, you need to use the format command. So don't mind the error there, don't mind it. So they declare it as format long. Want to have a better understanding of what format command is. Format long, that means we want more precision. So take x to be equal to 7 plus 10 divided by 3 plus 5 raised to the power of 1.2. Normally this answer is going to be in a very long format. So admit we didn't declare it as the formatting to be long. It will shrink our value, our result. So let me run this now. You see, this is about 16 digits after the decimal point. So you get it now. This same example now, let's assume I say format short for it. Format short. Okay, and I want to have the same value. See, what I did there is just to scroll up using my arrow key to scroll up. This same value now run. You see, it will break it into 3 digits after the decimal point. So that is all about formatting command. It's just a way of styling the result that comes out of your answer. So next we are looking at creating vectors. You all know what vector is from your high school mathematics. I'm sure you all know what vectors are. So let us clear, since we are doing something fresh now, always remember to clear if you don't need what is before the clear command anymore. So since I don't need them, I can clear. Now a vector is a one-dimensional array of numbers. Matlab allows creating two types of vectors. One, we have the row vector and the column vector. So row vectors are created by enclosing the set of elements in square brackets using space or comma to delimit the elements. So I want to create a column now. I will together. Let me create a row first, then we'll create a column. So let me take my row to be R. So R equal to, this is your square brackets. Let's take 7, 8, 9, and 10. Let's add 11. Then close the square brackets. So Matlab will take this as a row. Can you see the value, the output we have now? So this is a row. So now let's look at how to create a column. Now let's take C to be column, will be equal to, you still use the same square bracket, but you use semicolon to separate your elements this time. So the same elements too as we have in column. Let's have 7 colon 8 semicolon 9 semicolon 10 semicolon 11. Close with a square bracket. Now this gives you a column. Now have you seen that? So that's how to create a row and column. Hope you've seen that now. Yes. So that is all about creating rows and column. So we'll use more of these rows and column later in this course, but this is just the basics. So back to our outline. We'll be looking at creating matrices now. So hopefully this should be the last thing we'll be discussing tonight. So creating matrices in matrix, as you all know, is a two-dimensional array of numbers. In Matlab, a matrix is created by entering each row as a sequence of space of comma separated elements, and end of a row is demarcated by a semicolon. For example, let us create a 3 by 3 matrix. Let's create a 3 by 3 matrix now. So X now, look at it. I mentioned earlier that the end of a row is demarcated by a semicolon. So whenever you have a semicolon, that means you have finished a row already. So let's look at it. X, always remember to use your square bracket. So we have 1, use space to separate the rows, then use column, semicolon to terminate the row. That is a row. Then we are taking another row again, 4, 5, 6. Use a semicolon to terminate it. then we take 7, 8, 9. You don't need a semicolon now because you are closing the brackets. So Matlab, give me my matrix. So this is a 3 by 3 matrix. This is how wonderful that looks. I'm sure you like it. So that is how to create matrix. So this is the end of today's class. Hoping to see you tomorrow again. I'll be stopping the recording now. I still remain Ajibola Bolaji Jetro. Thank you for your time and thank you for staying tuned to the Matlab and Octave programming class. So see you tomorrow, same time and same venue. Thank you and have a good night rest. Good night.